Hello everyone, I am Ritesh. I'm a PhD student at the Department of Computer Science and Engineering in the Ohio State University, and this work is done in collaboration with my advisor, Dr. Arnab Nandi. So briefly, this is what our paper talks about. We talk about information extraction problem in this paper, more specifically named entity recognition from visually rich documents. We show that we can formulate this information extraction task as a span classification problem. We show that we can extract true instances of named entities from a document by classifying each span of visual area in the document as a true or false instance of that named entity. We further show that we can perform this classification task by featurizing each span of visual area as as a multimodal feature vector that incorporates domain-specific knowledge. Our experiments show that this improves the downstream performance of the information extraction task on multiple datasets. And finally, we present various machine learning-based techniques on how to perform this extraction task with minimal human supervision at each stage of the IE workflow. So this is a brief overview of what we are going to talk about today. First, we will motivate why it's important to extract information from visually rich documents and what are some of the challenges. Then we will present some key overviews and intuitions of the information extraction workflow we present in the paper titled Artemis. And finally, we will present some brief result highlights and key takeaways from our study. So, visually rich documents are documents in which not only linguistic cues but also visual features play an important role on the semantics. As you can see from some examples on this slide, that documents that are visually rich often will use visual features such as font size, color distribution, white space balance, and distance as important cues to highlight or augment various key entities in the document. Now, we do encounter such documents in our everyday lives in both physical and digital form. From posters, banners, forms, and magazine articles, these documents are everywhere. And they are also heterogeneous in nature, which means that they can originate from various sources, they can be of diverse formats, as well as they can have diverse layouts. What we also observe is that such visually rich documents are often a rich source of ad hoc information that is not always easily available to us otherwise. For example, whether it's a paper printed menu at your local cafe or a poster of a flash sale that you came across in the subway, uh, alternative sources of such data is not always available to us that are made available through such visually rich documents, which makes extracting structured information from such document an important task, because if we could automate extracting structured information from these unstructured or semi-structured documents, it would mean that it makes it easier for us to search, index, and query these documents using off-the-shelf tools. And it also would mean that it is easier for us to gather insights from this document with minimal human effort. Now, with this premise in mind, we present a formal definition of the information extraction task we solve in this paper, which is given a visually rich document D and a relational schema R. We want to extract a structured record D with schema R such that the record contains true instances of the named entities A1 to AN as entries of those columns in the record that we extract. Now, before we present our method, these are some of the limitations of existing works that we considered before implementing our solution. We first considered using text-based extractors, that is, we considered transcribing the document as raw text and apply off-the-shelf natural language processing solutions to extract named entities. However, what we observed that these transcription engines and especially this solution often resulted in serialization errors that led us to erroneous named entities extracted from the document when we didn't consider the visual cues when we were identifying the named entities that we were supposed to extract. We also considered the rule-based extractors where we defined custom masks for all the named entities that we wanted to extract. Although this is a better solution, what we noticed that this meant that we had to define rules for all possible layouts and named entities that existed in our corpus. Now, this made it a very difficult method to maintain and scale for large-scale heterogeneous datasets. With these challenges in mind, what we wanted out of this work is a generalizable solution that is not only robust for diverse document types but also is scalable in terms of reducing human effort at every stage of its workflow. which lets us formulate our solution in the following way. We observe that we can identify named entities from a visually rich document by classifying a span of visual area that appears in the document as a true or a false instance of the named entity that we are interested in extracting. We also observe that because we are formulating this task as a classification problem, that this also opens up new avenues to us for leveraging multiple machine learning based algorithms available to us from both computer vision and natural language processing communities that would help us reduce human effort at each step of this information extraction task. So that's essentially what Artemis does in this as a whole. So in our paper, we show that Artemis can extract named entities from visually rich documents using two steps. First, it would have to identify the candidate visual spans in the document where a named entity might appear. So to do that, we use or incorporate domain-specific knowledge in the form of weakly supervised functions that are multimodal in nature, which means that that we not only consider domain-specific knowledge in terms of text value matches, but also in terms of where the named entities might appear in the document, what font size it may use, what color it may use, etc. Now, once we had identified the visual spans where in the document, we could perform named entity extraction by performing supervised classification within the visual spans within these candidate areas. So this is a big overview or a broad overview of our workflow. As I talked about before, we started with a document and the list of named entities we wanted to extract. Artemis represents the document as a rendered image of itself. Then it identifies the candidate visual spans where a named entity might appear in terms of by using weak supervision. Then it performs classification within these candidate visual areas by transcribing and chunking the text appearing within each candidate visual area, featurizing them using context vectors, a local context vector that encodes discriminative properties surrounding the visual area in the document, and a global context vector that encodes discriminative properties of the input document itself. And then it concatenates them and then performs a supervised classification task and kind of decides whether it is possible for that text segment to contain an instance of the named entity that you are interested in. We performed experiments using this workflow on 4 visually rich datasets: the NIST spatial datasets, the tobacco litigation dataset, the MARC dataset, and the BRAINS dataset. If 3 out of 4 of these datasets are publicly available. The list of named entities that we used and the task we defined on each of the datasets are available in our paper, as well as in the supplementary document that we made available. So the metrics we used for our classification for this extraction task are accuracy at 1 and F1 score, where we considered our method as accurate if not only the named entity type we assigned to a text segment was accurate, but also the position where it appeared in the document was accurate as well. We compared our method against multiple strong baseline methods, and we performed comparably or better against all of these baseline methods in all 4 datasets. More experiments and analysis are available in the paper, but we won't go over them in details in this talk. So these are some of the highlights of our experiments. We get an improvement of up to 17 F1 points against a text-based baseline, and we show that against a state-of-the-art weakly supervised baseline as well as a graph-based method and commercially available tool, we perform comparably or better against all baselines on all datasets. We also observe consistent performance on diverse datasets for multiple information extraction tasks, which show that our method is promising and can generalize well to various document layouts and formats. So to conclude, these are our takeaways from the study. We presented and talked about Artemis, which is a visually aware information extraction method we talk about in our paper. In this information extraction method targets heterogeneous visually rich documents and extracts named entities from them. We show that this information extraction task can be formulated as a visual span classification problem, where each visual span is represented in a multimodal embedding space, and a machine learning based algorithm can be used to perform extraction by performing a binary classification task on that embedding space. Our experiments on 4 heterogeneous datasets show that our method is robust and generalizable to multiple datasets. So that concludes our talk, and you are more than welcome to attend our QA sessions where we could answer some of your questions. Thank you for listening and have a great day.